Okay, guys, here we go. This is going to be our follow-up to the first AX rule. This is AX rule part 2. And the actual assignment I want you to work on comes from the trig book. It's page 36, 31 to 42, and page 37, 61 to 66, plus number 75. But I never assume you have your book with you, and I need you to get your assignments done. So here we go. These are the problems I'm talking about from page 36. There's the answer key for the ones from page 36. And then here are the questions from page 37. Now, number 75, I chopped off the instructions because it's a big string of stuff, and they take a while to do those problems. So anyway, it says find the 5 remaining trig functions, and that's just for question 75 here. So here's the answer key for that stuff. All right, pause it, take a picture of it. You got it? Let's begin. I want to go through this lesson and just show you what they're talking about in the first section, which is this, and what they're talking about in the second section, which is this. And I call these math detective problems. You're just trying to be like a sleuth and figure out something. So it says, examples using the AX rule, identify the quadrants. Well, it could be quadrant or quadrants, because sometimes you could have an answer that works in more than one spot. So it could be like, hey, that's true about quadrant 1, or that's true about quadrant 2. Or that's true about both quadrants. So the first one, what are they doing? They're saying there is some angle out there. They're saying there's some theta angle that if you take the sine of that angle, it is less than 0, which basically means negative. And if you were to take the cosine of that angle, it would be positive. So what does that mean? Well, it means we're going to apply the AX rule to this, and I'm just going to quickly sketch out a rough coordinate system, and I say, okay, from what they told me, the cosine is positive. So where's cosine positive? It's positive in quadrant 1, and it's positive in quadrant 4. Why? Because of the AX rule. So anyway, I know that the sign is negative. Well, there's only one place where the sign is negative when cosine is positive, and that's in quadrant 4. So the answer here would be quadrant 4. Let's play with another one. Let's go to the next question. So here's the next question. It says, the tangent of this angle, tangent theta, is greater than 0. So tangent's positive. So let me stop for a second here, put the brakes on. I know that tangent, according to the AX rule, and I'm just going to keep doing this, tangent is positive in quadrant 1 because all of them are positive. Remember, that's what the A stands for. And tangent's also positive in quadrant 3. So what's the next hint they give me? Tangent's positive, but sine of that same angle would be negative. Well, it can't be quadrant 1 anymore because sine would be positive in quadrant 1. So it's got to be quadrant 3 would be the only quadrant where both of those things could occur at the same time. So I hope you're getting the hang of this. This is just detective work. We got to figure out, ooh, but now they're throwing secant at me. See, here's the one thing about the AX rule that I have not said anything about, but I'm sure you're going to come around to it pretty quick. If all the trig functions are positive here, meaning sine, cosine, and tangent, well, guess what? If you're positive, your reciprocal is positive. Reciprocal just means 1 over that number, so it's going to be positive also. So anyway, when they give me the AX rule, if cosine is positive, that means secant must be positive at the same time. Secant must be positive. Remember, in the AX rule, they use the big 3, cosine, sine, and tangent, but it doesn't mean that we can't think of it this way too. So when we think of it, we go, where is secant going to be positive? Well, secant's going to be positive wherever cosine's going to be positive. So that's in quadrant 1 or quadrant 4. But the other thing they told me here is cotangent is also positive. Well, the only place where all trig functions would be positive would be in quadrant 1. So I would say that is the only location where I could have those two things occurring at the same time. So once again, it's a process of elimination. You're being a math detective. So one last one right here. I would say secant is greater than 0 and cosecant is negative. So this time, secant greater than 0, so that's the same. I don't think in terms of secant, but I think that's the reciprocal of cosine. So it's either 1 and 4. And then I go, okay, cosecant is negative. Well, I don't think in terms of cosecant, but I would think that means sine must also be negative. And the only place that's going to happen where this occurs and this occurs would be quadrant 4. So once again, the first set of problems that I'm giving you guys to practice are just like that. A little bit of math detective work. Now, here's the second part. This is going to be a little bit more intricate, but this is a major skill that's going to come back to bite us. So please practice these and make sure you're getting them right. And if you're not, make sure you're coming into the Zoom room for extra help, because this is where you really need to make sure you're getting it down. It will not go away. So I have 3 examples here. My first example, says find the cosine of some angle theta if, and now they're giving me some information. They're saying sine of theta equals 6/7, but they're also saying that that theta is in quadrant 2. This means the angle theta is an element of quadrant 2. This is a symbol we use in math when we want to say belongs to or is an element of, and that's why they use this Greek letter for element of. So I got to hey, this is the same type of thing. This is an application of the Axe rule. I noticed that if sine is 6/7, they don't have a negative on that 6/7. That means that guy, that sine angle that they're talking about, is in this quadrant. See, this is a reference angle. The sine of that would be 6/7, so opposite over hypotenuse. But that means I have to figure out this little mysterious piece right here that I do not know. So I'm going to go, hey, this is another Pythagorean theorem thing, a squared plus b squared equals c squared. But since they talked about sine, I know that one of these legs is a 6. I know the hypotenuse is a 7. So I'm going to do a squared plus 36 equals 49. I'm going to take this away because I want to be able to cheer for this answer. And so I get what? That's 13. Are you ready? Okay. So I'm going to root. I get plus or minus. Ooh, guess what? You know what? I get plus or minus rad 13. Algebraically, that's what I get. But I'm going to go over here and erase my little question mark. See, I'm erasing the question mark there. You know what? I'm going to put a negative rad 13 there. I'm not putting a positive rad 13 there. Why? Because it's a reference triangle that I'm using to solve this problem. If they want me to find the cosine of that angle, I have to have the correct sign on this adjacent piece of information. The adjacent piece is on the negative side of the x-axis. If it's on the negative side, then I'd put a negative on it. See, you can have the cosine or sine or tangent or whatever have a positive or a negative vibe to it. Well, the cosine of this angle then, the cosine of that same angle would have to be adjacent over hypotenuse. There you go. That's the type of answers you are going to find. They're going to be weird little root answers, or maybe you get lucky, you get whole numbers. But let's look at the next example. And if by going through this, you're like, wait a minute, negative pieces of the puzzle, etc., maybe you should review the lesson that came right before this one. Or better yet, if you're still confused, jump in the Zoom room. I got nothing but answers for all your questions, but I got to tell you, they want me to find the cotangent for this one. But they're telling me the cosine is 2 rad 3 over 5, which happens to be a positive number. It is. That's a positive value. So that means this 2 rad 3 over 5 is either in quadrant 1 or quadrant 4. Axe rule. Oh, baby. But they also tell me that the sine of this thing is negative. So there's only one place where cosine is positive and sine is negative at the same exact time. That would be quadrant 4. So I would have to draw my reference angle, or reference triangle, sorry, in quadrant 4. And this is the angle I would use to represent this cosine. So I'm going to say cosine means adjacent over hypotenuse. And by the way, hypotenuse is always positive. When we do any reference triangle work, the hypotenuse is never the negative. So you can see that the adjacent side, and I'm going to highlight it a little better this time. The adjacent side here, I'm drawing in red. That's on the positive side of the x-axis. It's a positive value. But you can see that the opposite side here is on the negative side of the y-axis. It's on the negative side of the y. So whatever answer I get for this piece, it's going to have to be negative. Then I can go back and I'll have all three sides and I can find my cotangent, etc. But let's play. We're going to do, okay, we got some leg of this triangle we don't know, plus this one that we do know, equals 5 squared. I'm just going to call it 25. Now, here's the thing. 2 rad 3 squared. 2 rad 3 squared means 2 rad 3 times itself. So on the outside I get 4, this times this. Inside I get 3. That's a fancy way to say 12. And then I'm going to take it away, take it away, take it away now. And I get a squared equals 13. This is just a coincidence that it came down to be plus or minus rad 13, but we already know it's not a positive 13. That would be crazy talk. This guy is on the negative side of the y. It's a negative. Now, I don't know about you guys, but I personally do not think in terms of cotangent. I don't, and I'm really good at math. I think in terms of tangent, and then I flip my answer over. So I would say the tangent of this thing would be opposite over adjacent. That's what I would think. And then I'd just rotate that in my brain. So if I want to find the cotangent for something, my brain thinks tangent and then it thinks reciprocal. So if I did opposite over adjacent and then rotated that in my brain, this guy's going to end up on the top and this bad boy is going to end up on the bottom. Now, I cannot leave a rad in the bottom. None of my answers will have that, and I will have to totally come down on you for doing that. Polite mathematics, we get the rad 13. Oh, that little piece of my coordinate system is going to bug me there. I'm going to try and get rid I thought that would happen. Hang on, let me get this. Okay. So anyway, I didn't want you to think there was a rad 113 in there. So here we go. That turns out to be 2 rad 39 over 13, but I know it's negative. I know it's negative. Because the only guy that's positive in quadrant 4 is cosine and secant, not cotangent. But I don't want to leave the minus on the bottom. It's a bad habit, so I just stick it on the top. Beautiful. Looking beautiful. That's my answer. Cha. Let's do our last example. And remember, you can pause this, you can rewatch this, you can do whatever you need to grasp it. And if not, you come back to the Zoom room and ask me. They want me to find secant. I can tell you right now, I do not think in terms of secant. I think in terms of cosine. And then I flip the answer over. But it says if cotangent, oh crap, I don't think in terms of cotangent. I think in terms of tangent. But where are they trying to stick me? Where are they trying to turn this thing? Well, I know that if cotangent is positive, so is tangent. And cosine's negative, there's only one place that's going to happen, and that would be if I was in quadrant 3. So I'm going to draw my reference triangle in quadrant 3. And I'm going to put my theta right there, and I'm going to say cotangent rad 3 over 3. No way, I'm going to just think of it this way. Tangent would be this guy. Because me, opposite over hypotenuse. Now I feel much better about that. Because, yeah, the other way, I don't think about it. Ugh. Now, they want me to find the secant. So that means I do need to know what the hypotenuse is, or I cannot do this. So I'm going to do a squared. What the heck? I'm just going to jump right into it. A squared. I'll call that guy a squared. And then I'll do b squared, right? Then I'll do b squared. And then I'll do c squared equals c squared. Now, here's the problem, though. I wanted to see if anybody caught my mistake. Because this is the most frequently messed up thing that people do. Hey, cotangent's positive. That means tangent must be positive. That is true. That's not a lie. But why is it positive in quadrant 3? Because, see, look at this. I'm going to color code this again. And then let's go back and get a blue. Do you guys see that this guy should have been negative? He's on the negative side of the y-axis. Do you guys see that this guy should have been negative? He's on the negative side of the y-axis. But you know what? If you do the tangent of it, it's because you got a negative over a negative, right? If they're both negatives, they're going to cancel. But that's going to change. That will mess with my calculations for secant. I got to be super cautious here. So, negative rad 3 squared, yeah, it's still 3. Negative 9 squared, yeah, it's still 9. It equals c squared. So I go 12 equals c squared, root, and then I go, wait, I can clean that up. That's the same as 4 times 3, so I pull it out. I go plus or minus 2 rad 3. But I mentioned this in my last problem, so I want to make sure you know it. The hypotenuse is never negative. Hypotenuse of any right triangle is never the negative piece. But now I can find secant. I can find the secant of this. Me personally, I'm going to find that cosine, and then I'm going to take the reciprocal of it because my brain thinks in terms of cosine. So I would say adjacent over hypotenuse. That's what I would do. And then I would say, hey, look at that. Beautiful. Bam, bam. Those both cancel. So I have negative 1/2 for an answer, but if I take the reciprocal of that answer, then I'll have the answer they wanted. The reciprocal they wanted, negative 2. So you guys have seen the axe rule before. I called it axe rule part 1. But this is one of the ways we use the axe rule to help us calculate missing lengths, or just to determine which quadrant we're supposed to be in when we do our calculations. So, you can't go through the rest of this trig part of our lessons without kind of having a little concept to this. So if you do have questions, please ask, because it won't go away. You'll see it again. All right, guys, that's it. Let me scroll back up before I close this thing out. And just remind you, these ones are just math detective work. And if you get them right, then your answers match right there. There really is no work to show me other than you draw a coordinate system. And you don't have to draw a brand new one each time. You could just have it at the top of your page for the axe rule. And then these ones are just like the ones I just showed you. All right, but they're a little bit kinder to you because they tell you which quadrant to look in, but not on number 75. Number 75, they do not tell you which quadrant to look in, but you can deduce it. You can do your detective work. Also, number 75, they ask you for all 5 trig functions, so that's why there's more answers for 75. And you'll see, 61, 62, you luck out on those ones. They're nice and pretty. But get the sign right, because that's what's important, making sure you're in the correct quadrant. All right, guys. So until next time, bye-bye.